Okay, guys, let's start the session. So, actually, in the last session, we discussed about the control groups and namespace in the Linux operating system, which is the primary cause of creating the containers. These are the main features that are helpful for you to creating the containers in the Docker. So, what is a container? Again, coming back to the main concept over here, what is a container? Container is a process which is running in a Linux host, or else which is running in the Docker engine, which is hosted on the Linux server. Linux or else any servers you can talk it out. Okay, so container is a process running on the Docker engine, which will be having the application and its dependencies, a package of application and its dependencies. That is what we call it as a container. Now, when you see here, whenever we are discussing about the Docker, first things first, what we need to understand here is Docker architecture and then how this Docker will be working. So initially, whenever we are creating or else whenever we have installed the Docker, yesterday we have seen how we are going to create the Docker or else how we are going to install the Docker in the Ubuntu operating system. Not only Ubuntu, you can install that in the Red Hat also. Okay, Red Hat operating system, yum install Docker, that will be installing the Docker over there. So the point what you need to understand here is this is your server. Whenever this is your Docker host, simply I will call it as Docker host. Nothing but the server or Ubuntu server or also Red Hat server or Windows server, anything. So inside this server, inside this Ubuntu machine or else inside this Linux server, what we are doing here is we are installing the Docker engine. We are installing the Docker engine. Okay. So this is my Docker, which we have installed in the last session. Now, what I'm going to do here is, after installing the Docker, what is going to happen? Just to try to understand, let me do one thing. I will remove this server and recreate a new server so that you will understand how we are creating or else how we are installing the Docker inside the Linux operating system. The same can be happen whenever you are having an on-premises environment also. If you are having an on-premises Linux server also, the same thing will happen. Let us see what is going to happen over here. Okay, just give me 1 second, guys. 272 I73. Okay. Now what I will do here, I will go back. I will go back and try to remove the. I will go back and try to remove the this particular or else try to terminate this server. Okay. So I will explain you how you can create the servers in the AWS environment. If you are having an AWS account, you can create this server. Best case, I will try to explain you in the next session, tomorrow's session. Once the demos are completed, I will try to explain you in the next session. Anyways, coming back to the point, Docker host. Okay, so I'll go with the Ubuntu operating system. That 2204 is the best one. Okay, and then T2 micro is fine. Okay, I'm taking here. There is no system requirement for installing the Docker. I'm going with 1 CPU and 1 GB of RAM. And then what I will do, I will go ahead with the public subnet. What are all this? I will try to explain you in the next session. Don't worry about this configuration. What I'm doing in between, I mean, in front of you. Okay. Keeper will be default. Right. Now I have my server. In this server, I don't have any sort of Docker installed. Whatever the server that I have created right now, this is the server. Inside the server, I don't have any Docker application installed. Now, what is my requirement here? I want to install the Docker. Before installing the Docker, let me show you something. So this is my Docker host. Let me copy the public IP. Good. My server is spinned up. Okay. Now, what is my requirement over here? So if you can see here, I will give a command called as ifconfig. To know the IP address of the server, I will go with the ifconfig. There is no certain utility. What I will do, I will install that on my Linux machine. So this is my server. Right now, whichever we have deployed over here, this is the Docker host which we have installed. Okay, Docker host server which we have installed. Now inside this, what I'm trying to do here is I will install the Docker. Before I install the Docker, let me show you one thing. If config. Now here you can see I have Ethernet adapter. Okay, so for any server you will have an Ethernet adapter. For you also in your desktop also you will have an Ethernet adapter to access the internet. Wi-Fi adapter you will call it as, or else LAN port. Okay, likewise in the server also you will have an Ethernet adapter that is called as ETH0. This adapter is helpful for you to connect to the internet. Okay, it is having an IP address 10.1.249. This is the IP address of that particular adapter. So this is called as a private IP. Okay, this is called as private IP. And there is a public IP assigned for your server. So this is the public IP which is assigned to your server. Right. So this is the Ethernet adapter which is helpful for you for your server, whatever the server or else whatever the EC2 instance that we have deployed in AWS environment. With the help of this particular server, we are able to communicate with the internet. Okay, this is one adapter. We are able to communicate with the internet. We are in the sense the whatever the server that you are hosting, the server is able to communicate with the internet. Okay, so if you can see here, ping google.com, I will get a response. So if I don't have that Ethernet adapter or else any network connection, I won't be able to get the response from the internet. Okay, so this is fine. Now we are having another adapter. This is called as loopback adapter. LO means loopback adapter. It will be available in each and every computing device. Either it might be laptop, you will have a loopback adapter. Either it might be your desktop servers, anywhere you will have the loopback adapter for testing purpose. Especially this is for the testing purpose. Apart from this, we are not going to use anywhere this loopback address. Okay, these are the two addresses that we are having, which means two adapters that I am having. One is Ethernet adapter, that is ETH0. Okay, this is the adapter which is helpful for your server to communicate with the internet. Okay, now I will install the Docker. So simply one command which is helpful for me to install Docker is curl-sl https://get.docker.com and bash. So this symbol is called pipe symbol, the vertical symbol, vertical line, whatever you are seeing, that's called as a pipe symbol. Okay. When I hit enter over here, what is going to happen? Docker will be installed. Now, after installing Docker, you will find out a certain difference. I will show you that. What is going to happen over here? Okay, hold on. Come on. Just stay with me. Hold on. Hmm. Yeah, now Docker is installed. Now if you can see Docker PS, so right now it is installed, that is fine. Now what you need to understand here is before when I give the command if config, what is the difference that you find out when I give if config previously and what is the difference that you find out if when I give if config now? What is the difference that you are getting out here? Previous command and this command. Previously also we have given if config, right? At that time, what is your observation? Now what is your observation? You didn't observe anything. Guys, come on, speak out, please. Am I audible? Yeah, I think I am audible to you. Do you understand my question? Can you please give me an answer for my question? What is the difference that you find out when I give if config previously and when I give if config command now? Go on, guys.
So the if config you gave it at Ubuntu, and after if config you give it for the Docker.
No, both are the same. I have given on the Ubuntu environment itself. In the if config, whatever I have given, it's very simple. Can't you able to see this? Look at here. If config, when I give this command, it is showing you two adapters. One is
Yep.
Ethernet 0 adapter and loopback adapter. When I give the if config after installing the Docker, how many adapters you are able to see here?
Around 3.
Three. One is the Docker 0 adapter, Ethernet 0 adapter, and loopback adapter. Which means that what is
Yep.
evident in this example, after showing you this, whenever we
With
install the Docker, automatically a network adapter will be created. Which type of
created.
network adapter it is? It is a bridge network adapter. Am I clear here? So what is this
Yep.
bridge network adapter is going to do? Whenever we install this application Docker, automatically a bridge network adapter will be created. So now what it is going to do? Whatever the isolated containers that are created inside the Docker environment, I said you the containers will be created, right? So if these containers need to access the internet, first of all, what they will do here is by default, they will be connected to this bridge network adapter. Whatever the containers that we are creating, all the containers will be connected to this bridge network adapter. By default, they will be connecting. If we don't specify the network, they will be connected to the bridge network adapter. So now what is going to happen here? So whenever they request any data from the internet, the request will be going to the bridge network adapter, and from the bridge network adapter, it will be reaching to the server adapter, and from the server adapter, the request will be reaching to the internet. This is how the request will be reachable to the internet. So whatever the adapter that is created after installing the Docker, that is called as a bridge network adapter, which will establish the communication between the containers and the external Ethernet adapter. Okay, so now by default, whenever you create the or else whenever you install the Docker network, the default network which will be created is in the range of 172.17.0.0/16. In this range, the default network will be there. Okay, which means that whatever the container that is created in the default network 172.17.0.2, this will be the IP address of the container. So if you want to check out this, let me show you one thing. Docker network ls. So write down these commands. These are very, very important, guys. Every time I cannot repeat it. Whenever I am giving you the lecture itself or else training itself, just note down the commands. This will be helpful for you. So Docker network ls, here you can say whatever the network adapters that are available, the Docker is displaying them. What are those? Host network adapter, nothing but your Ethernet 0. Host in the sense the server. Okay, server Ethernet adapter. This is called as, otherwise called as host network adapter in the Docker terminology. And this is called as a bridge network adapter. As I already showed you, bridge network driver is bridge network adapter. And there is null adapter. Null means loopback adapter. So these are the three adapters that are available in your system currently. Okay, so the Docker is recognizing three adapters. Among those, host adapter is attached to the server. Bridge adapter is created after installing the Docker, which will be establishing the communication between the container and your server. Now, if you see Docker network inspect bridge, if you give this command, it is going to show you the properties of that particular network adapter. Now, look at that. So there is a adapter called as bridge adapter created, and this is the ID of the adapter, and driver is bridge adapter, and what is the subnet 172.17.0.0/16. That is what I have said you. The default IP address whenever and bridge or else whenever the Docker is installed, a network adapter will be created or else a network will be created that is called as a default bridge network. Okay, when we install the Docker, let me explain you. When we install Docker, a network adapter or else a default network will be created. Default network will be created. That network will have 172.17.0.0/16 as the network. Okay, or else under that network you will have. Okay, so whenever you install the Docker in any server, if you install in your system also, in your computer also, you will get an IP address 172.17.0.0. This is the default network adapter when you install the Docker. So now what I will do here is I will try to create the containers. I'm going to create the containers. So let me try to create the containers like container 1 and container 2. Now what is going to happen? Let me show you that. So this is the container 2, which will be created. If I don't mention the network, automatically the containers will be created in the default network. 172.17.0.3. That will be the IP address of that particular container. Now let me go back and create the container over here. Docker ps-a. This is the command which will be displaying you about all the containers, whatever the containers, running containers, stopped containers, newly created containers. Every container will be displayed with the help of the command docker ps-a. Hyphen a in the sense show all the containers, not only running containers. Any containers, whether the state might be stopped, whether it might be created. So all the containers will be displayed with the help of this command. Right now, I don't have any containers running. So what I will do, docker run -itd -name container1. This is the name of the container with the help of the image Ubuntu. So now what is happening over here? The container got created. Okay, so let me show you that docker ps container 1 is created. So now I want to know the IP address of the container 1. How I can know about that? Docker inspect, use the command docker inspect container 1. So here you can see the container 1 is having the IP address 172.17.0.2. That is what I have given over here. 172.17.0.2. And if I create another container, docker run -itd -name container 2, and with the help of Ubuntu image, I'm going to create with the same image. Okay, docker ps. Here I am having two containers, container 1 and container 2. I just want to inspect the container 2 also. Container 2. So here you can see the newly created container is having the IP address 172.17.0.3. So whatever the containers that are created, all the containers are having the IP address in the range of 172.17.0.172.17 range itself. Now try to understand in this format. Let me show you one thing. Docker network ls. So I want to know how many containers are attached to this bridge network. Docker network inspect bridge. Here you can see container 1 is attached, which is having the IP address 172.17.0.2, and container 2 is also attached to the bridge network, which is having 172.17.0.3, and these two containers are connected to the default network. Now what I can do with this? So first of all, what we have done, we install the Docker, and when we install the Docker, automatically a bridge network adapter will be created. Now I have installed, or else I created two containers, and automatically if I don't specify the network, automatically they will be created in the default network. So whenever I am giving the command, I did not mention any network over here. If you see docker run -itd -name of the container and just the image I have given. So what is happening over here? It is created in the default network. Try to understand this. Now, whenever these containers are installed on the default network, now they will communicate with each other. They will communicate with each other. Let me show you that. So I want to go inside the container. I want to go inside the container. How I can go inside the container? Docker execute -it container1 and bash. So right now I am inside the container. Which container? Container 1. So right now I am inside the container 1. So apt update -y and apt install -y IP utils hyphen ping. If you have any questions, you can ask me. Okay, don't hesitate to ask the questions. Any question it might be. It might be a silly question. It might be tough question. Any question. Okay, we are open to answer all your questions over here. Don't sit idly and don't sit in a confused state. Anyways, so right now in which container I am? I am in the container 1.
Container
So
1.
I will try to communicate with the container 2. What is the IP address of the container 2? That is 172.17.0.3. 172.17.0.3. Look at there, I am getting the response from the container 2, which means that both the containers are in the same network so that they will be communicating with each other. But in the default network, there is a problem. What is the problem means? The communication will not happen through the name. So if I try to ping container 2, ping container 2. So see there, it is saying that I am name or service not known. It is throwing you an error that I don't know what you are asking for, what you are asking me to ping for. So which means that the default network, inside the default network, the containers cannot communicate through the name. Sir, what is the necessity of having this naming communication? Already containers are able to communicate with IP in the default network, right? Okay, then what is the need to communicate with IP? What is the need to communicate? What is the need to communicate with name? Why it is required? So that is the question here. And but before that, what you need to understand, default network, the containers in default network cannot be able to communicate with name. Okay, that is the point what you need to understand. Now, why they need to communicate with the name? It's a very simple logic. For example, I am having a container in the network. Just assume that I am having a container which is hosting an application. Okay, this is an app container. So this app container is connected to a database container. So database means which will be helpful for you to store the data. Just simple words I am telling you. There is a DB container. Inside the application, what I am doing here is I am telling to the application. So for example, this app container is having the IP address 172.17.0.some100. This is the IP address of this particular app container. And this database container is having an IP address 172.17.0.101. Okay. So now what is my requirement here? I am telling to this application container, to the application that if you want to save any data, then you have to connect to this particular database. So I will give it like Postgres ://172.17.0.101. So now what I am telling to my application application. So if you want to save any sort of data, then what you have to do here, you can save the data inside the container which is having the IP address 172.17.0.101. But crucial point what you need to understand here is containers are stateless. Containers are stateless. What is meaning of stateless? If suppose there is a sudden load increased on the container, if the CPU requirement is increased on the container beyond its working capability, the CPU is more utilized. The containers will be terminated. The containers will be removed. The containers will stop and automatically they will be terminated. So now what happens? Suppose, for example, due to any reason, this database container is deleted. Due to any reason, if the database container is deleted, in place of that database container, a new container is got created. Okay. So in production environment or else in the company environment, what is going to happen? Within minutes, multiple number of containers, new applications will be created, new containers will be created. So what is going to happen? Even though if the Postgres database container is deleted, so before I monitor it, before I check out that the database container is deleted, eventually in the place of that particular container, some another new container will be, random container will be created. So for that random container, it is going to be, the IP address is going to be assigned like 172.168.0.101. So this is for a random container. It's not a database container. Now, can you tell me what is going to happen in this scenario? Whether the data is going to be stored on this random container, whether this application will be able to communicate with this random container. Is it going to happen? So what is going to happen now? So this application container will not be able to recognize this random container. What is this random container? Actually, it should be like a database container, right? But why we are having this? Why we are having this random container? So now what this application will do? The application will be failed. So this container is also going to be terminated. That is the case which we can see over here. So to overcome this process, what I'm going to do here is, in place of IP addresses, so in the Postgres, in the application, I will give the container name. So my application has to communicate with the container name. So I will give like Postgres or else Postgres DB. So this is the name of the container. So now what should be happen? The name resolution should be done. So without the name resolution, you are unable to communicate. Okay, so this is the main point. This is the main reason why we need to have the name resolution happens between the containers to make the communication. So now what is going to happen? Even though if the database container is deleted and a new database container is created with a new IP, but still the name of the container should be the same. So that the application container will easily resolve that particular name and try to connect with that database container. So simply, if I have to say there are two people, okay, or else suppose let me suppose think that you went for a conference, okay, you went for an official conference where there are some thousands of people are attending to that conference, and your employee ID is somewhere like in your office, your employee ID is 105. Okay, in some another office there is a person with the same employee ID 105. In some another office, there will be some same employee ID with the 105. There are multiple people having the same employee IDs will be attending to that particular conference. If I call employee 105, so how many people will react for that? Whoever are having the employee ID 105, everyone will react for that. If I say the person from Infosys or else the person from Wipro with the name Chaitanya or else with the name Kumar, he has to attend to this particular venue. If I say that, then obviously all the remaining company people will be sit silent and only the people or else only the person from that particular company will be ready. So the name resolution will be happening even though if you are having multiple employee ID, still you are doing with the help of name resolution. In the same manner, here also it is going to happen. So if there are multiple containers are running, suddenly if the old container got deleted and the IP address of that old container is assigned to a new random container, then there will be a problem faced by the application container, which should not be happened. To overcome this problem, what I am trying to do here is I will make the containers to make the communication with the namespaces or else names. Name resolution should be done. But what is the problem with this particular scenario? In the default network, the containers will not be able to communicate with the name. In the default network, the containers will not be able to communicate with the name. So now what I have to do? So that's the $1,000 question over here. Are you able to follow my flow? Is there any confusions over here? Are you with me? Are you able to understand what I'm trying to explain you here? Any questions up to now? Everyone?
Yeah, good.
Yeah, thanks. Any another person? Are you able to follow me? Are you able to what I can say? Are you able to understand what I'm trying to explain you? Everyone? Right. So let me go with the next one. So in the default network, we are unable to communicate with the name resolution. The name resolution will not happen. To do the name resolution, to do the name resolution between the containers, we are going to install a new network adapter. Okay, a new network adapter. Okay, so this is our custom network adapter or else user custom created network adapter. Okay, just give me a second. So look at here. Look at here. Right now, how many networks that we are having? We are having only 3 networks. Now I will create a network adapter. Docker network create, for example, testnet. This is the network adapter name which I am giving. So here you can see Docker network ls. Previously, we are having only 3 network adapters. Now we are having the 4th network adapter that got created. It is testnet, which means that this is the default network adapter that is created after installing the Docker. Now we created a new network adapter. It is also a bridge network adapter. Now, what is my requirement? I need to disconnect these containers from the old bridge network adapter, and I need to connect it to my new network adapter, new custom network adapter, testnet. Okay, so this is what I need to do right now. So the default IP address range will be 172.18.0.0.0/16. This is the default network adapter range. Okay, so now what I will do, I will remove these 2 containers from this default network, and I will connect these 2 containers to the new network adapter which I have created. Okay, so now what is going to happen? It is also a bridge network adapter, which means that it will be connecting to my external network adapter like how the old default network adapter used to do. So now let me remove this IP address and this IP address as well. So a new IP addresses will be assigned for the containers, both the containers. Right now, Docker network inspect testnet. By default, there are no containers connected to my new network, custom network, which we have created. Now what I will do, Docker network disconnect container 1, disconnect bridge from container 1. So I am trying to disconnect the container 1 from the default network adapter and as well as container 2 also. Right now, what has happened? 2 containers are disconnected from the bridge network adapter, default bridge network adapter. If you want to check out that, Docker network inspect bridge. Look at that. There are no containers on the bridge network adapter, and as well as Docker network inspect testnet. In the testnet also the containers are not there, which means that we are disconnecting, or else we already disconnected 2 containers. Right now they don't have any IP address. For example, let me go into the container 1. Docker execute -it container 1 and bash. So now I am inside the container. If I go for if config, oh, sorry, apt, yeah. Now try to understand now. Now I will try to install the net tools. Apt install -y net-tools. Okay. See there, it is trying to connect to the internet. What happened here? These 2 containers are either or else neither not connected to this bridge network adapter nor connected to this new test network adapter. So they are in the Docker itself. They don't have the internet connectivity. So that's the reason here you can see failed to fetch. Okay, which means that they are not connected to any network. They are not connected to any network adapter, so that they are unable to communicate with the internet. So now what is our requirement? I need to connect these two containers to the custom network adapter which we have created. So Docker network connect testnet for the container 1 and as well as container 2. Now if you see Docker network inspect testnet, previously for this network adapter we don't have any containers. So see here, this is the Docker inspect testnet. Previously we don't have any containers attached to that particular network adapter. Now what is going to happen? See there, container 1 and container 2, both the both the containers are connected to the testnet with the IP address 172.18.0.2. The test container or else container 1 is having the IP address 172.18.0.2 and container 2 is having 172.18.0.3. So these are created or else these are connected to the new network. Now these two are connected to the new network adapter which we have created. Now let me log on to my first container. Docker execute -it container 1 and bash. I am inside the first container, ping container 2. Look at that. I am getting the response from the container 2 with the name resolution. So right now we are having the name resolution. Previously we got an error, but with the custom network adapter, we are able to communicate with the name resolution. It is going to do the name resolution and I am able to ping to the other container with the help of name also. So this is the main difference between your default container and the new network or else custom network adapter that has been created. Sir, what is the reason? So Docker even not given the reason for this. They said that we are providing the default network adapter to make the communication between the containers through the IP address. If you want to have the communication through the name, then you can go with the custom network adapter. So that is what the answer that the Docker is also given. You can check out the official Docker notes also. Okay. So this is about the networking concept of your Docker. Understood? Any questions over here? Any questions, guys?
Yeah, my question is why it is switching from bridge to testnet. So by default, it comes with the bridge, right? When you create a Docker containers. So what would be the benefit if you go converting into switching into the bridge to test
You saw everything.
in production environment? So in actual environments, what would be the benefit?
You saw everything, right? What is the problem with the default network? Yeah, my question is that what is the problem with the default network?
Because
You saw,
that naming
you saw from
names,
start.
we are unable to communicate with between the containers.
Yeah, but with the
So
custom network adapter,
so we can able to communicate. That is what reason.
that is what. So if I
Okay.
show you an example, you will understand that. But now the point is, try to remember that the custom network adapters we are able to communicate with the help of name. Okay.
Okay.
But when I
Okay.
show you the example, you will get a clarity about this particular thing. Okay.
Okay.
Anyways, I will show you. But as of now, just remember this particular concept. Okay.
Sure. Sure.
Right. Any questions?
So
Yeah. Go on. Sorry.
the bridge. So bridge will be ideal. It will not be using anymore, right?
Yeah, if you want, you can use by default. So I said, if you don't provide the network name, for example, I try to create another container. Let me try to create another container. Docker run -itd -name container 3 with Ubuntu. If I am not specifying any network here. Okay, I did not specify any network. So now where it is going to be created, Docker network inspect bridge. Look at that. Into the
Created.
default network adapter, what is happening? Container 3 is created. If I specify the network name, so again, I will try to create one more container over here. Container 4 hyphen network. Okay, hyphen network testnet. Now, what is going to happen? This container 4 is going to be created in the testnet.
Testnet.
Okay, if you don't specify the network, then automatically they are going to be created in the default network. If you specify the network, then they will be created in the whatever the custom network that you have provided. Okay.
So it cannot be pingable container 3 from container 3 from test.
You are asking that there are two networks. One is testnet and the other one is a bridgenet. Whatever the containers that are created in testnet can't be able to communicate with the bridge network. That is what your question is all about, right?
That's
You can do that with the help of network routing. You can do that, but that is not required over here.
okay.
Right. Any other questions? See, let me go through this. Docker container communication between networks. Okay, you can see that Docker containers generally communicate within the same network, but do not directly across the different networks without specific configuration. To enable the communication between the containers in the different networks, they need to be connected to the same network either by adding the shared network, creating a new network for them to connect, which means that routing we have to do. Okay. Any which ways, this is not that much important for you right now. Just we are going with the containerization concept. I will try to explain you if there is really required for you. Okay.
Okay.
Right. Simple. Here you can see. Look at that. Docker run hyphen network gateway network. Okay. This is for one of the network, and there is another network hyphen network knet1. Okay. Two containers are created. So now what we have done, Docker network connect both the networks. I'm trying to connect both the networks so they will communicate with each other. Okay.
Okay.
Right. Yeah. Any other questions, guys?
So can we create the network routing between default and the custom network? Can we create? Okay.
We can. There is a possibility, but that's too. I don't discuss right now. It's technically too in deep of concept, which is not required for you in this moment.
Okay. Thank you.
Ajit, Anil, Shivam, Suresh, any questions?
I'm good, sir. Thank you. Yeah. Relax,
Sorry, Suresh, your voice is breaking.
I don't have any questions, Chaitanya. And
Right.
today is completed demo section.
Yeah, I will talk about that at the end of the session. Not right now. Fine, yes. Yeah. So let me go with the next one. So this is about your Docker networking. Not only that, if you want, you can create your customized network. If you want whatever the IP address, the range that you want to create, you can create the subnet range. You can do all the things. Okay. So just for a briefing of concept, this is how your networking will be configured. Now, after installing Docker, what is going to happen over here? What is the Docker architecture? That is very important. See, whenever we want to communicate with the Docker, what we are doing, we are giving certain commands. What is that? Docker run, Docker stop, Docker rm. So that's called as Docker CLI. So the interface between the user and the Docker. Okay, interface between the user and the Docker, we are having Docker CLI. In the CLI, what we are going to do, we are giving the commands like Docker run, Docker build. Build is not that come. I will show you about that. And then Docker start. Okay, these are all the commands that we are running. Not only that, Docker execute, Docker network create, Docker network disconnect. Anyways, whenever we are creating anything at the beginning, we are giving a word called as Docker, which means that we are having a Docker CLI. We are communicating with the application called as Docker. So this is the user interface. Okay, user interaction point where we are going to interact with the Docker CLI. In the back end, there will be a Docker daemon. In my Ubuntu operating system, we will have a Docker daemon. Okay, so this is my Docker daemon. Now, whenever you give the command, the command will hit to this Docker daemon. Okay, so now what is the command I want? I want to create a container. Let us suppose think I will remove all the containers, whatever the containers that we are right now we are having. I am going to remove all the containers. Docker PS. Right now we have 4 containers. Docker rm-f dollar docker PS -a, which means that I am going to remove all the containers with the help of this command. Okay. What it is saying, docker PS. Okay, docker PS -a. Right now, do we have any containers running? We don't have any containers running. So what is the image that we are having? We are having an Ubuntu image. So to know the images that are present in our server, in our Docker server, we are going to give the command docker images. So it is going to show us it is going to list out the images that are available in the Docker server. Right now we are having the Ubuntu latest image. Now what I will do, I will remove that image also. Docker rmi, this is the command to remove the image. What is the image? You can give the image ID or else you can give the image name also. Ubuntu latest. So now if you see Docker images, right now we don't have any sort of images available in my Docker server. Okay, so let me do one thing. Good. Now, if you see, when I give the command docker run, which means that I want to create a Docker container. I want to create a container. Now this run command will hit the Docker daemon. The run command will hit the Docker daemon. Not only run command. If you want to build the image, you can give the Docker build command. If you want to start the container, you can give the start command. So any which ways, when I give the Docker run command, it is going to hit to the Docker daemon. So in the Docker daemon, it will be communicating with the containers, or else it will be communicating. It is going to check the images. Okay. So through which image he wants to create the container. So right now, if I give the command docker run -itd -name test is the container name with the image Ubuntu. If I give this, now what is the image that I want to create? I want to create the container with the help of the image Ubuntu. Now this Docker daemon will check in the local registry. Okay, this is called as local registry. Whatever the images that are available in my server. Okay, this is called as local registry. Okay, my whatever the images that are available, all the images will be available in the local registry. Now it will go and check whether the images are available in the local registry. Right now we don't have the images in the local registry. Docker images. We don't have any images available in the local registry. Now what it is going to do? Then if the images are available, it will be creating the containers. Okay, if the image is available, then it will create the containers. But right now, what is happening? We don't have the images in our local registry. Then my Docker will be checking in the global registry. It will go into the internet and it will check in the default Docker global registry that is called as Docker Hub. Docker Hub. Docker Hub is a global registry where you can have all the images, all the Docker related images available publicly. So if I go back to my internet, hub.docker.com, I want to have my Ubuntu image, right? Simply I will check out Ubuntu. So look at that, I have my Ubuntu image available for me. So from this particular repository, so this is called as repository, guys. Whatever the image related configuration that you are seeing, this is called as a repository, and this Docker Hub is called as a registry. So it will go to the Docker Hub and check for the repository, whatever the image that the user is requesting for. User is requesting for an image repository called as Ubuntu. So it will check in the Docker Hub whether that particular Ubuntu image is available. Now I have just shown you that the Ubuntu image is available. Now what is going to happen? This particular image will be pulled from the Docker Hub to my local registry. It will be pulled from my Docker Hub to my local registry, and then it is going to create the container with the help of the image which I pulled. It is going to create the container with the image which I have pulled from the Docker Hub. So now if you can see, let me try to create it. I'll give it over here. Docker run -itd name of the container is test, and with the help of the image Ubuntu. So if I don't mention any version tag over here, colon 2204 or 2404, like that, any version number I did not mention, it is going to pull the Ubuntu latest image. Okay, so now if you see, I don't have any image in my local registry. So now what it is going to tell you, unable to find the image Ubuntu latest locally. I am unable to see the image in the local registry. So now what I will do, I will try to pull that from the Ubuntu, pull this Ubuntu image from the default Docker Hub, whatever the default Docker Hub that you are having. From this Docker Hub, I will pull the image with the tag latest. Why? Because I did not mention any tag. So whatever the image that is having the latest tag, it is going to pull that particular image. Latest. There you go. This image will be pulled from the Docker Hub, and then it is going to create the container. Now we are having the test container which has been created from this image. If the image is not there, then the containers won't be created. So what is the container? Just we have created test. Okay, so from where this container is created? This container is created with the help of this Ubuntu image. Whether this Ubuntu image is available in our local registry, it is not available in our local registry. So what has done? So my Docker daemon has pulled that particular image from the Docker Hub and stored it now in my local registry. Now the Ubuntu image is available in the local registry. Now from now onwards, if I want to create any container, it is not required for me to pull that particular image. I am going to create a new container test2. So look at that. This time I am not getting this message, unable to find the image Ubuntu latest locally. So why? Because already the image is available in my local registry. In my server registry, I already have my image. So it is going to create my container with the help of this particular image. If the image is not available, then only it will go and check in the Docker Hub, or else in your private registry also. If the image is available, it is not going to check in any registry. It is going to check in the local registry and it will create the container. So this is about your Docker architecture. Now let me go and show you that. Docker architecture. This is what we have discussed up to now. Look at that. So Docker client, nothing but Docker CLI. Whenever we give the command, it will go and hit to the Docker daemon. If the images are available in the local server registry, it will create the container. If the images are not available, it will go and pull out the images from the Docker Hub. Or else you can build your own images. If you want to build your own images, images will be built and it will be stored in the local registry. And with the help of this created new images, we can create our own containers. So this is the actual Docker architecture. I hope both are the same. Okay, I hope you understand the concept. Any questions here? Any questions related to the Docker architecture?
So whenever you create images, it will by default it stores in the local registry, right? So if
you explicitly create the images, they will be stored in the local registry. Otherwise,
okay.
Docker will be try to pull the image from the Docker Hub.
Okay.
If it is not available in the local registry.
Okay.
Right. Questions, guys? Right. So what I will do, I will stop here. As you can see, it is about 8 o'clock. I will stop here. Do you have any further questions? You can ask me. You are questionary. And this is the last and final demo. And from tomorrow onwards, those who have enrolled for the course, they will get a new updated link. And through that link only, you will be able to join into my classes. Okay. Now your questions. Waiting. Questions, guys? See, it's very important to ask the questions so that at least if I am unable to answer, or else if I am or else I will be able to understand whether you got, or else you are in the same line with me or not. At least I know about that. If you don't ask me any questions, then no use of it. Okay, attending to the sessions are also no use of it. I can clearly say that. Again telling you the
Yeah.
truth. Actually, here you are attending for the sessions to gain the knowledge. Okay. So if you hesitate to ask the questions, I don't know how many faculties will ask you this, but if you hesitate to ask the questions, then it's useless to attend the sessions. If you think me badly also, no problem. But questionnaire is very important for any candidate who are attending to any session, who is a student actually. Yeah.
Hey, sorry to ask you this question again. The Docker Hub, how it will be, is it comes with the Docker installation, or we need to create
No,
sub?
it's we don't need to create it. In general, that
Okay.
the Docker will understand about that.
Okay.
Okay.
So if you have NGX image, if you want, so it
Hmm.
will take it from the Docker Hub, right?
Yeah, it will take from the Docker Hub, or else you can, if you don't have the image in the Docker Hub, then you have to create that particular image.
Okay.
For example, let me tell you, you are creating an application for your company. Okay, for your company, you are creating the application. That won't be present in the Docker Hub, right? Generic images will be available. Now, your
That's right.
requirement, the Docker Hub doesn't know, right? Or else the users who are in the Docker Hub doesn't know your requirement. You have to create your own image. How we are going to create that image, that you will see in the next upcoming sessions,
Okay.
right? Yeah.
Okay. Yeah. Means kind of a Docker Hub means it's a kind of a repository which is globally available. That's
Yeah, it's a globally available repository.
okay.
Okay. Yeah. Just simple. Just compare it with Git. You know Git, right?
Oh, yeah, I know a little bit of Git. Yeah.
Yeah. So whenever if you don't know about any coding and everything, you will simply pull the Git. You will simply pull the repository from one of the developer who has created that particular code, and you will utilize the code in your project. If you know what you want, then what you will do, you will generate your own code and you will push it into the GitHub so that other people will be able to access it. It is as simple like that. The Docker Hub is also the same. But in
Okay.
spite of code, what we are pushing here, we are pushing the images.
Okay.
Right? Yeah.
Okay. Thank you.
Questions?
The class will start same time, sir, correct? Tomorrow, or it's
7 o'clock. 7 o'clock, 7 to 8. This
7
week,
o'clock.
totally, it will be 7 to 8. And from next week onwards. Why? Because at 8 o'clock, I am having one more new batch scheduled from tomorrow, the same Docker and Kubernetes batch, where it will be started tomorrow. Okay. But eventually from Monday onwards, most probably from Monday onwards, you will have the sessions at 7 to 9 o'clock in the evening.
Okay.
Right. Tomorrow also 7 o'clock, guys. Okay. Yeah. Okay, everyone. Have a nice day, and we'll meet in the next session. Tomorrow will be the most interesting session where we are going to learn about container lifecycle and then the Docker images and lot of things to cover. We need to close the Docker at any cost. We need to close it by most probably. Why? Because tomorrow's batch is also going to be merged into your batch. Yeah, by 7th of May, we have to complete the Docker, and from 8th onwards, we need to start Kubernetes. Okay, so we are into the initial stages only. Anyways, I will try to figure it out how I can take the classes out of things. So my planning is that I have given you 20 hours of session. So from 8th, we will start the Kubernetes mostly. 8, 9, 10. Mostly my thinking is that I want to complete the sessions by 24th of May. That's my tentative date. Let's see what is going to happen. Are we able to complete it? I also don't know. I will check it out. And if there is any new things that are available, then definitely it is going to take 1 or 2 days extra also. Okay. Have a nice day, and we'll meet in the next session. And don't forget to enroll yourself. And this is the last session that you are attending for a free demo. From next session onwards, you have to enroll for your course. So have a nice day, and bye-bye.
Thank you. Thank you, sir.
Thank you.